After learning about the sp3 hybridization, we will now learn about sp2 hybridization. For those who are still unclear of sp3 hybridization, be sure to re-watch the previous video. For sp2 hybridization, it's formed by hybridizing the 2s orbitals and 2 of the 2p orbitals, resulting in 3 sp2 orbitals. The other 2p orbitals remain unchanged. Okay, so initially you have the 2s orbitals and 3 2p orbitals. However, during the mixing or the hybridization, only one, the 2s orbitals mix with 2 of the 2p orbitals to form 3 sp2 orbitals. There's one 2p orbitals that do not undergo hybridization. It remains unchanged. Let us take a look at sp2 hybridization in carbon atom. The electronic configuration of carbon is 1s2, 2s2, and 2p2 at the ground state. Okay, so it's 2s2 and 2p2 at the ground state. During the excited state, one of the electrons get energized and move to the higher energy orbital, 2p orbitals. And during the hybridization, only one of the 2s orbital mixed with 2 of the 2p orbitals. In total, we still get 3 and call it the sp2 orbitals. And one of the 2p orbitals remains unhybridized. Okay, if we look at the diagram, the sp2 orbitals, they have energy that are in between. Okay, that means they are higher than the 2s orbitals, but they are lower in energy than your 2p orbitals. And for the 2p orbitals that did not change, it still remain at the same energy level as the 2p orbitals, okay, as shown in the diagram. So all the 4 orbitals, they will have 1 unpaired electrons, each for sharing with other atoms to form 4 bonds. The 3 sp2 orbitals, they are arranged in trigonal planar shape. Okay, we call it a trigonal planar shape for your sp2 orbitals. And the 2p orbitals that is not hybridized is perpendicular to the sp2 orbitals. So you can see this shape over here. Okay, the sp2, they are arranged like in a triangle shape. We call it a trigonal planar. And the p orbitals, they are perpendicular to the sp2 orbitals. And for the nitrogen atom, okay, the electronic configuration at the ground state is 1s2, 2s2, 2p3. 1s2, 2s2, 2p3 orbitals. And when they get excited, one of the electrons actually move to a higher orbitals level, the 2p orbitals. And during the mixing, the 2s orbital mix with 2 of the 2p orbitals to form 3 sp2 orbitals. And one of the 2p orbitals remain unhybridized. So the electrons will be like this, okay? So you have one of the lone pair at the sp2 orbitals. So the sp2 hybridized nitrogen has 3 unpaired electrons for sharing with other atoms to form 3 bonds. The lone pair is not for bonding. Nitrogens will form 3 bonds. Okay, so as seen from here, this is the shape. Okay, you have like the sp2 orbitals here and the p orbitals that is perpendicular to the sp2 orbitals. For the oxygen atom, the electronic configuration of oxygen is 1s2, 2s2, 2p4. 1s2, 2s2, 2p4. And during the excited state, one of the electrons actually move up to the 2p orbitals. During hybridization, the 2s orbitals mix with the 2p orbitals over here to form 3 sp2 orbitals, leaving 1 2p orbitals as unhybridized. So the sp2 hybridized oxygens will have 2 unpaired electrons for sharing with 2 other atoms to form 2 bonds. The lone pairs are not for bonding usually. Okay, so you have 2 electrons, 1 at the p orbitals, 1 at the sp2 orbitals, and 2 lone pairs at the sp2 orbitals. After learning about the sp3 and the sp2 hybridization, we are now at sp hybridization. This means that one 2s orbital mixed with one 2p orbitals, and this results in two sp orbitals. The other two 2p orbitals remains unchanged. Okay, as we can see from here, you have two s orbitals and your 2p orbitals, but only one of them mixed with one of them to give us two sp orbitals. The other p orbitals remains unhybridized. That means they do not change at all in their shapes. Okay, and the way you draw the orbitals diagram is as shown as here. Okay. Let us take a look at the electronic configuration of carbon. Okay, at the ground state, carbon is 1s2, 2s2, 2p2. During excited state, one of the electrons from the 2s orbitals move to the 2p orbitals. And during the mixing, only one of the 2s orbitals mix with the 2p orbitals, okay, to give us two sp orbitals. And two of the 2p orbitals remains unchanged. So we have the two sp orbitals having two electrons, one electrons each, and the 2p orbitals having one electrons each. So the four orbitals, they will have one ampere electron each for bonding with other atoms to form four bonds, because carbon can form four bonds. The two sp orbitals, they are arranged in linear shape, okay, here, linear shape, with an angle of 180 degree. The two other 2p orbitals, they are perpendicular to the sp orbitals. Okay, let's look at another example in nitrogen atom. The electronic configuration of nitrogen is 1s2, 2s2, 2p3. So you have the 2s2 and the 2p3. And one of the electrons will actually move up during the excitation state, and they will mix. Okay, remember, for sp hybridization, one of the 2s orbitals will mix with one of the 2p orbitals, and we'll get two sp orbitals, and two of the p orbitals remains unhybridized. And the three orbitals, one sp and two 2p orbitals, they will have one electron each, and one of the sp orbital will have the lone pair. Therefore, the sp hybridized nitrogen will have 3 unpaired electrons for sharing with other atoms to form 3 bonds. The lone pair is not from bonding, so usually nitrogen form 3 bonds. So you see there's 2 sp orbitals. One of the lone pair is in the sp orbital, the other lone pair is also at the sp orbitals. Then you have the p orbitals, in which you have 1 electron each. Okay. To summarize, in the ground state, your carbon, your nitrogen, and your oxygen, okay, they may remain in the 2s orbitals and the 2p orbitals individually, as you have learned in your previous module. However, during the hybridization state, okay, for hydrogen, it remains unchanged. It's still at the 1s orbitals. However, for carbon, nitrogen, and oxygen, in the hybridization state, you have the sp3 hybridization, in which 1 2s orbitals mix with 3 2p orbitals. In total, you get 4 sp3 orbitals. For the sp2 hybridization, you can have carbon, nitrogen, oxygen. For sp2 hybridization, as the name implies, you have 1 s orbitals mixed with 2 of the p orbitals to give us a total of 3 sp2 orbitals. Okay, and these sp2 orbitals, they are arranged in a shape that is called trigonal planar. Okay, and the p orbitals is perpendicular to the sp2 orbitals. Okay, so for the carbon here is, remember, it's a tetrahedral shape and the angle is 109. And for sp orbitals, okay, as the name implies, there's 1 s orbitals mixed with one p orbitals. That means one of the two s orbitals mixed with one of the two p orbitals to give us total of two sp orbitals. Okay, and the p orbitals, they are perpendicular to the sp orbitals. Okay, so how do we remember whether is it sp3 hybridization or sp2 hybridization or sp orbitals? We will find out in the coming videos.